another window. I have to click the teams, then 2-3 windows. I have to come out, then I have to mute it. Things are not easy. It's not like Zoom where I'll mute all. So this option is not available for me. I have to come out of the main screen again. There I have to mute all of you. Please see that maximum unavoidable, okay, but maximum intentionally don't like switch on your microphone because it's like a get added up lot of noise. Okay, so let me take a slab. This is slab. So let there be a ray. Let it pass through a slab. Let me take another ray which is passing through or external to slab. This is slab. Thickness of slab, let it be D. So here the surrounding medium in the slab, the light will propagate with a speed v1. Here I'll take it down. Whereas in there, let it propagate with a speed v2. Is it okay? So there's a light. What do this arrow? It's a light propagating. Let mu be the refractive index of the slab. We know you go back to the ray optics, refractive index, something we discussed, no? Like when we ray moves from one medium to another medium, its speed will change. So what is the speed of light in any medium? By C by mu. What is the speed of light in air or vacuum? Similarly, here at t equals 0, the light will we call this time t, it will emerge out. The light will take some time. It will to pass through this slab. So what is the time taken? Let it be t. Similarly, in the same time, what is the distance covered by the light ray in air? That will.
Sir, your voice is not clear.
We'll do one thing. So how much distance it will cover here? Voice is not clear. Okay.
It's breaking in between, sir.
No.
It's breaking, sir.
Are you able to? Now also? Switch it off video, no? Your network is causing poor call quality. Try to switch into a better network. Or can you hear me now? Anybody?
Yes, sir.
Yes, sir.
Sir.
Voice okay? No problem now? Shall I continue?
Yes, sir.
Yes, sir.
Fine. Thank you. Okay, this let the distance covered. Let the distance covered by the slab in time t. So we write that is v1t. So this will write it as ct by mu. In the same interval of time, the distance covered by the ray in air. So that will calculate. So definitely it is moving with a speed, more speed, no? So it will cover some more distance than this. That t equals 0 entered, at time t equal to 2, it will be here. Find this one, so it will cover a distance x2. So we'll calculate what is x2. X2 equal to, we write v2t or ct. So from substituting this here, ct I can write it as mu x1. Okay, now see here, no, if in a time interval, this one what, so let me write here. A medium of refractors, how much of distance it will move in air or in vacuum in the same interval of time. That is called like a mu d. This mu d is called like a optical path length of the ray moving in a slab. So how to interpret it? Simplest, shall I put in simplest way? Like if I move in a slab, I take a time t to move through this slab. I'll cover a distance d. In the same interval of time, how much I will move in air or in vacuum, it will be mu d. The optical path length of the ray moving in air. Or how to interpret in both the length. If a ray covers a distance d in a medium of distance mu in an interval of time, then in the same interval it covers a distance mu d in vacuum. So this particular mu d is called like a optical.
Your voice is breaking, sir.
I'll make some adjustments. Now okay? Can you hear me?
Yes, sir.
Some voice filter, I did adjustment. I don't know how far it will work. Can I continue?
Yes, sir. Yes, sir.
Yeah. Okay, thank you. Okay, I'll come from here. Like a ray 1 will move. So there's a, you can put like a ray 2. There's a ray 1. Ray 1 moves like a distance d through a slab. What is the thickness of slab? D in a time interval t. So what is the distance covered in the slab? We write it as x1 equal to v1t. What is v1? Speed of the ray 1 in the slab, which is c by mu. So ct by mu, what distance covered by the ray 1 when it moves through the slab. In the same interval of time that the ray which is moving outside this slab, let it cover a distance x2. What is the speed of the light in air or vacuum? Well, let it be say equal to c. So distance covered by the ray outside this slab will be ct, that one. So I'll replace that one. So I get something this one. So what is the meaning of this? Means if a ray covers a distance d in a slab or in a medium of reflectance mu in an interval of time t, in that same interval it will cover a distance mu d in particular. Mu d is called like an optical. Based on this is what we are going to do plenty of problems. Okay, is there any path difference between these two rays? Any path difference? It's the path difference. The path difference between the rays is called, I'll call delta x. I'll write it on top, which is equal to x2 minus x1. So what is x1? Mu d. What is equal to d then? So how much it will be? Mu minus 1 into d. So this is the path difference of the rays between when a ray moving through this slab and this one. So like this, what happen if I want to introduce a path difference between the rays? What shall I do? Just bring a slab of thickness d of refractance mu in the path of one of the ray. Then the two rays, what happen? They'll encounter. They'll encounter a path difference that we can calculate by this one. This is a formula. So what is d? D is the thickness of slab. That red color I indicated here. So how to define optical path length? They may ask definition in mains. You have to be very careful, even in advance also. What is the optical path length? If a ray covers a distance d in a medium of refractance mu in an interval of time, comma, in the same interval, the ray covers a distance mu d in vacuum. That mu d is called as optical path length of the ray. Okay, this is about the initial thing. What happens if the medium surrounding the slab is other than air, so other than vacuum? So suppose it's some liquid, let there be some liquid. Then how to calculate that optical path length or path difference between the rays? I'll move to the next part. Okay, there's a ray 1. It will pass through the slab. And the other ray, so what is the medium surrounding it? Let me write mu naught. So let it be liquid. The medium surrounding the and the slab. Refractive index of slab, let it be mu. Thickness of slab, let me take that is equal to d. At t equals 0, the ray will enter here. At t equal to t, it will do. So let v1 be the speed here. Let v2 be the speed. Again, similar condition will put. At t equals 0, the ray will enter here. Then after some time t, it will be available here. We'll calculate what is the path difference. There's a ray 2, two arrows I'm putting. Ray 2. This is a ray 1. Similarly, we'll calculate. So first we'll calculate what is the distance covered, x1. Speed v1, v2, first we'll define them. v1 is equal to c by mu. Then x1 equal to v1t, v1t, and v1 is equal to. Similarly, what is v2? v2 is the speed of the light in the medium, in the surrounding medium that you can call as a liquid. So this will be c by mu naught. So what is x2 is equal to? x2 is equal to v2 into t. What is the value of v2? c by mu naught t. You write like this. Ct, let's replace there. From this, I'll replace Ct. x2 will be, Ct value will be x1 by mu naught. How you should interpret and what is x1? x1 is what? Say previous problem, mu naught if it is medium surrounding the slab is air, or say let it be equal to say some water, say like some vacuum, then mu naught will be 1. So if there is any surrounding medium, if there is any medium surrounding the slab, then that you have to bring mu naught in the denominator, that you remember like this. So what is the path difference? Path difference delta x is equal to x2 minus x1. So x2 will be mu d by mu naught. And what is x1? x1 is equal to d. Look at the diagram here. So this will be mu by if there's any medium surrounding this slab, the equation will come like this, mu by mu naught minus 1. If the medium surrounding the slab is air, so we just put mu naught equal to 1, mu minus 1 d will be the path difference between the rays. Now, very important, almost every numerical will be bringing a slab in YDC experiment. So we need a background of this one. So what you have to check, what is the refractive index of the slab, what is the thickness of the slab, and what is the medium surrounding the slab. That also you have to make observation. Okay, take this, we'll go for YDSC. Completed? Please somebody switch off, mute it. Huh? Okay, now let me introduce the slabs. So there are two slabs which I picked up. There is a slab of thickness T, I'll write it.